Hey everyone, welcome to the webcast today. I'm Torey Penrod-Cambra, I'm the Chief Communications Officer at HighByte, and I'll be your moderator for today's discussion. So I'm excited to be here today for a session we're simply calling UNS to Snowflake with my colleagues Jeff and Aron, who I'll introduce momentarily. But first, do a little housekeeping here. Nothing out of the ordinary. Of course, this broadcast will be recorded and shared. The slides and images, anything you see here, diagrams, reference architectures, they're available on request. Just reach out and let us know. And then I'll ask you to use the Q&A tool throughout the discussion. You can use chat to connect with each other, but the Q&A tool is going to be the best place. We have our colleagues John and Brad online today, ready to answer your questions. And hopefully we also have some time for live questions at the end of the webcast. When you log out of the webcast, you also see 2 brief exit survey questions. If you wouldn't mind taking the opportunity to answer those, that'd be great. Let us know how we're doing. So with that, let's talk about why we're here. For the next 55 minutes, you're going to hear firsthand from Jeff and Aron about some of the new capabilities that are available now in HighByte Intelligence Hub version 3.3, and you'll see live demos. But we won't just talk about the what and the how, we'll talk about why and what these capabilities mean for your business. So as promised, some of the agenda was pre-shaped by things that we felt were important to cover. But there are plenty of questions woven throughout this agenda that were submitted by our registrants, and you'll see those pop up throughout the webcast. So big picture wise, first, we're going to look at the benefits and limitations of a UNS architecture. Jeff is going to share some reference architectures, and Aron will discuss in more depth with demonstrations. I'll also show you how to land contextualized model data in the Snowflake data cloud, and that's important for reducing compute latency cost. So we'll get into those details. And then we'll also look at how and why to query Snowflake tables that might be required for use cases requiring closed loop event handling from the edge, so cloud back down to edge. And along the way, you'll see Aron use pipelines replay. It's a new capability available in version 3.3 to monitor and troubleshoot your data pipeline health. So we have a ton to show you today, and we're going to jump in shortly. First, I'm going to launch a poll just to get a baseline sense of how familiar you are with HighByte Intelligence Hub. I saw a lot of new names on the registration list, which is awesome, but might want to just take a little bit of time to talk about HighByte and HighByte Intelligence Hub before Jeff and Aron jump into it. So yeah, today you'll be hearing about Sparkplug, historical data, future of UNS, and so much more. Great, okay, I see poll questions coming in. Poll responses, I should say, poll responses coming in. It looks like right now, predominantly, people are familiar with HighByte Intelligence Hub, but not using it regularly. So this is good. And then some folks are brand new. Great, okay, what I'm gonna do then is, I'm gonna close this poll. That's really helpful to know. And I'll give you a very brief introduction to HighByte before you see more. So who is HighByte? At the highest level, we're on a mission to provide manufacturers with the digital infrastructure we believe is critical for digital transformation success. And our industrial data ops software solution, HighByte Intelligence Hub, enables us to deliver on that mission for our customers. Since founding the company in 2018, our customers now span 18 countries and 20 different vertical markets, many of which you can see here, including life sciences, automotive, pulp and paper, and many more. And of course, we're supported by a global network of distributors, system integrators, and technology partners that help support this growing base of customers. So about HighByte Intelligence Hub, what is it exactly? Well, you'll certainly see more of it today, But we talk about HighByte Intelligence Hub as an industrial data ops application. It's built for industrial data, typically deployed at the edge. Its purpose is to deliver modeled, ready-to-use data from any asset or system to the cloud, using a codeless interface to speed system integration time and help accelerate analytics and other use cases. With the Intelligence Hub, data engineers can merge machine data, transactional data, time series historical data from a variety of edge data sources into a single payload, and you'll see why that's so important today. And they can use the Intelligence Hub to standardize and contextualize information models in real time. For me, I think the most exciting part of the Intelligence Hub is that it truly provides a collaborative environment for OT and IT. So everything you would expect on the OT side in terms of connectivity to OT systems, no code, low code interface, and then also everything you would expect from an IT application. So containerization, federated architecture, and advanced administration features that manufacturing IT has really come to expect. So now I'd like to introduce our panelists. Jeff is a product manager at HighByte, focused on product positioning, technology partnerships, reference architectures. He's an experienced technologist who brings more than a decade in technology leadership roles in the automotive and discrete manufacturing industries to his role at HighByte. And Aron is our CTO, focused on guiding the company's technology and product strategy through R&D, technical evangelism, and supporting customer success, and agreeing to do webcasts like this one for me. So Aron has more than 15 years of experience in industrial technology, and he has some great content to share today.
Only for you, Torey. Only for you.
Thank you. It's going to be a good one.
Yeah.
So let's just jump right in. Jeff, I'm going to pick on you first for the warm up. We've titled this whole thing UNS to Snowflake. Let's start from the beginning. What is UNS? What is unified namespace? Or in the very least, how do we define it here at HighByte to sort of level set before we get started?
Excellent question. Yeah, this comes up. I think it can become a very broad topic just because industrial environments can be very unique. They're very implementation specific, but a lot of people think of it as the structure of a business and its current events. And sometimes that can be a bit nebulous, but I think it's always helpful to kind of go back to the foundations of what does industrial data look like? Why do we have the problems that we do? So if you think about the traditional Purdue stack or ISA 95 levels and such, you have a variety of different nodes, right? And when we say namespace, we're often referring to the native representation of data in these systems. And when we think about how factories are built, they're not necessarily built around standards. Yeah, there's a couple of exceptions in some industries from time to time where standards might be applied in some sense. But really, if you think about it, it's like, industrial automation, it's a very, very long life cycle. It lasts for a long time. There's mergers and acquisitions, different people program things, certain devices and technologies go out of spec. They have to be modernized and so forth. And as a result, you just have to kind of deal with the namespaces as they exist. And sometimes you can kind of modify them, but there's also really practical questions about, should you? Is it too expensive? Is it too resource intensive to do so? Are there validation constraints, right? So at a high level, namespaces in the kind of native nodes that we have in an industrial enterprise tend to be very sticky. The concept of UNS, as the name implies, it's referring to an abstraction layer whereby we're unifying, as the name implies. We're unifying those disparate namespaces. So instead of showing data how it looks like in one of those source systems, we're organizing information in such a way that it's recognizable to a person other than someone who, say, programmed a machine or is the domain expert of setting something up, right? So the idea is that they can go into a unified namespace. They can see a structure that resembles their business. So that could be by asset hierarchy, that could be by business units, that could be organized by teams, that could be organized by asset type, even use case, right? But the idea is that someone from the outside who's not necessarily a domain expert should be able to go into that unified namespace and it should look familiar to them. It should resemble the reality of their business. And then more importantly, under each of those kind of topics, right, there are events, typically happening on a pub sub basis, on change and so forth. But there are practical concerns to how this is sort of built, right? A lot of times when people think about UNS, they're only focusing on telemetry because, as you know, MQTT, its origins are in the energy industry. It was mostly surrounded around, how do we take, remote instrumentation or devices in the field, and how do we move them up to a SCADA across, constrained, limited wireless networks and such. But when you think about, an external user, right, not the person programming the machine, not the person, running some specialized manufacturing application, to an external persona, a lot of times their use cases or how they want to consume information, it's actually scattered around many different systems. So when they want to get a holistic view of what's happening to a production line or an asset, they often need to pull from multiple systems to really get a full picture of what's going on. And so the benefit of a UNS is that it's not just that we're organizing different pieces of information in our industrial environments by hierarchy or by some structure, right? But the idea is that we're curating, recognizable, contextualized, payloads that are relevant to the way that we want to consume information. And a lot of times people think that, all it takes is just to publish into these things. All I need is MQTT and I can make this happen. But we often sort of forget that we can't just neatly plug into these things. Not everything is centrally orchestrated. There is no central orchestration of all, 10,000 PLCs you might have in your enterprise or the unique MES that you have at every site. You can't snap your finger and expect them all to publish data consistently. And so that's where data engineering becomes very necessary. And that's where we focus at HighByte on. So, up and down the stack, there are different types of data. And we have to think about interoperability is not necessarily a protocol problem, but it's a payload problem, right? Anyone can convert protocol A to protocol B, but ultimately there's different types of data and their interfaces and their data sets impose constraints on our architecture. There's transactional data, so MES systems, ERP systems, basically anything with a database connector or an API. There's historical data, on the southbound side of the stack in the OT layers, we have, good old process historians and such. But as we go further up, there's a lot of time series tools now showing up in the cloud. And then, of course, there's telemetry data in such in the OT layers, but increasingly we're seeing a lot of telemetry being utilized in the cloud. So the question is how do you make this all work? How do you build that all? And that's where data engineering comes in. But one of the key observations that we've observed over the past, I would say really sort of years, that there still seems to be a big emphasis on getting data into the UNS. And what we really wanted to focus on this release, as we've really enhanced our interoperability with specific cloud services and databases, is getting data out of the UNS. So that is putting our UNS data to use, allowing people to do something useful for it. But to get data out of it, it's not simply an exercise of plug in MQTT or do pub sub, right? These systems can be very sophisticated. They're very nuanced in how they like to ingest data. So in this release, we've added a lot of new capabilities that allow us to gracefully and intelligently deliver data to cloud services and other data stores. We focused on schema creation and dynamically updating schema based off of model changes. We focused on streaming capabilities, so the ability to move in frequently updated pieces of information, as well as to be able to handle bulk and historical data moving in. We've had existing capabilities around buffering and compression, and we also have some interesting new capabilities regarding writebacks. So just as moving data out of the UNS and doing something, a lot of times these applications or services can have insights and we can pull them back down.
Jeff, so good. Thank you. And actually you tee up the next question perfectly, which I'll jump to next, which is, as promised, we told you we would answer your questions if you submitted them in the registration form. And I love this question from Alex because he minces no words. He just jumps right in it. What's HighByte got that Snowflake hasn't got? How do the two work together? You may have seen our partnership announcement this week. And obviously we've added a lot more bidirectional interoperability in version 3.3 with Snowflake. So how do these solutions work together, and what's the difference between the two of them?
Fantastic
Jeff,
question.
I'll kick that back to you if you like.
Yep. So first, I think it's helpful to start off with what is Snowflake, right? Snowflake is I kind of think of it as this hybrid data warehouse, data lake. People use it in different fashions, but I kind of think of it as it has the ease of use of a data warehouse. You get good old SQL. It's familiar to use on some level, but it has a lot of kind of NoSQL underpinnings underneath the hood, right? It's very flexible. It's very performant and scalable. It's showing up in a lot of IT departments. If you talk to sort of people who what's happening in their business intelligence teams, what's happening in among their data scientist personas in their organization, Snowflake is showing up a lot. And I think the OT realm or the people in the industrial world are saying, "What's all that about? I'm very focused on data. How do I get involved in that?" In Snowflake, because it's very relevant among the IT realms, people are using it with CRM data, their human resource data, their sales data, their ERP data, and so forth. Those types of IT data sets are very relational, right? But when you think about industrial data, it's very, very raw. We already talked about, there's lots of different varieties of it. There's machine and telemetry. There's transactional. There's historical and time series. There's even files. If you go to a lab environment, at a life science customer, some of these obscure machines don't even have a protocol. They just spit out obscure files. And the other aspect is that the data really is in such a raw form that's very difficult to construct relationships off of it. Oftentimes, at most when you're kind of pulling an industrial device, you're lucky to just get a timestamp and some cryptic name value pair, some weird identifier, right? If you try to move that into Snowflake, it's not that Snowflake doesn't have it's not that there's a technological limitation. It's simply just an issue of domain expertise. Someone in Snowflake may not necessarily who's working in Snowflake may have not necessarily programmed PLCs directly on their shop floor. They don't have the domain expertise of all the specialized systems that might be involved in operations, right? So what Intelligence Hub essentially can do is take that raw industrial data and make it usable and basically accelerate its use with Snowflake. In this release, we've added a lot of specific capabilities that sort of underpin our broad strategic partnership with Snowflake. For a while, we've had the capability of moving data in via bulk to Snowflake. So we've had native support for the major cloud object storage services, and this really works well for moving bulk historical data into there. And that works with the Snowpipe services. And I think it's really important to kind of understand that there's not just one way to moving data into Snowflake. There's a lot of different ways, and some are better than others depending on your use cases. The most exciting thing that we've added in this release is we added a direct native connector to the Snowpipe streaming API in Snowflake. That provides the lowest level of latency. It doesn't require any third-party applications. It directly builds out schema and hydrates that schema with the lowest possible latency and compute. It's excellent for streaming data into Snowflake. Additionally, we've had some existing connectivity with respect to with streaming. We have Kafka support, of course. So some organizations that may have a Kafka infrastructure already set up with their Snowflake environment, we can certainly coexist with those as well. And finally, the last new interface that we've built out is a Snowflake SQL connector. So now we have direct read access to Snowflake tables. So as you stream data in, whether that's in bulk or in a streaming fashion, and you generate insights and do calculations and so forth within Snowflake, that data does not just have to reside in Snowflake or in your business intelligence layers. That data can actually be read in to Intelligence Hub, say published back to the UNS or written back to some OT system. So those insights could show up on an HMI or some sort of alerting system that the operations personnel within your organization may use.
Perfect. So you know what my next question is going to be. Aron, I'm looking at you. Can you show us this?
Share my screen, then unmute. Yes, absolutely. Am I ignition? My ignition trial just this is good timing because I can reset this so it doesn't die when we're mid demo. So yeah, so let me jump in quick. I'll show two things. I'll show why you want to model your data at the edge. So what I'm going to do first, I'm just going to push raw data into Snowflake. When I say raw data, I mean OPC data, and you'll kind of see what that looks like. Then I'm going to model it. I'm going to push it into a broker and show you how you can either go direct to Snowflake or through the broker to Snowflake, and the flexibility there. So to do that, I've got a Kep Server EX here. That's my OPC server. I'm going to pull everything under what I call Packer tags normal. So what I've tried to do here, usually in my demos, I have these like nice clean tag names, but I want to get a little more real world, right? These tag names are not nice and clean and self-descriptive. The story is when the engineers set this up, right, they were thinking about how I get this into the HMI. They were not thinking about how do I make this globally identifiable for this machine. So this is an example of that. You can sort of make sense of this, but not well. So what I've got here is I'm going to go to all flows. So I've got some Snowflake flows here. And what I'm going to do is in this flow, and then I'll jump out and kind of show the Snowflake connector after I turn this on. What I got is these, I've grabbed these raw tags, right? And if I test read these, you'll see there's a value, tag name, quality, timestamp. It's typical OPC data. I'm just going to grab a few of them and I'm going to send them up to Snowflake in what I'm calling a raw tags table. And this is a Snowflake output. So I'm just identifying the table I want it to land in. And I got create on. If we jump out one more and just look at the Snowflake connector, there's some basic settings. Our user guide shows how to set this up, but certificate-based authentication, et cetera, to connect out to my Snowflake instance. So if I turn this on and hit save, and then I go up, and this is kind of the Snowflake worksheet interface. Like Jeff said, this is very SQL-like. I think on the back end, it's not SQL, but they do a very good job of making it very familiar. Select everything from raw tags. When I do this, it'll pull up the table. HighByte's created this table on our behalf. It's used the data model from the data we were looking at, and I'm landing. So that quickly, I'm landing, machine data into Snowflake. And you can see it's exactly what you'd think: value, quality, timestamp, tag name. So, if this is one packing machine, these are packing machines. My demo's like, assume it's a fertilizer plant. There's a packing machine at the end of the line that's putting the fertilizer in bags, right? So you can kind of make sense of this. There's bad. That's the bad count of like bad seals in the bags. There's a good count. There's a rolling count, minute hour. Like this kind of makes sense, but it's kind of hard. So you could probably bring on the other packing machines and sort of make sense of it. But then you bring on additional machines. You get 100 tags, 1,000 tags, 100,000 tags, and suddenly you've got people from the factory sending you spreadsheets of what these tags actually map to, and you're trying to create another table in Snowflake to give you the metadata for the tags. This quickly becomes very unmanageable from the Snowflake. So you're about as far away from the factory as you can get, and this is the only information you have to make sense of what that thing is. All right, so what's the alternative? The alternative is to model at the edge. So in here, I've created in HighByte. This is kind of HighByte, some 101 stuff, so I'll kind of fly through this. And there's other YouTube demos on this, but I've created a data model. So the data model says this is what all of my packing machines should look like. It's a schema. I can set data types. I haven't done that here, required fields, etc. And then I'm going to create an instance of a particular packing machine, in this case, packing machine 1. And what I didn't show is I've connected to that OPC server. And I can browse that OPC connection from here. And what I've done, pre-demo is I've just kind of drag and dropped the different tag references, because I, in the factory floor, know that the bad tag is the bad, or links to bad seals, right? So I've linked that here. I've actually pulled in some OSI Pi data here, so I can mix data. I can do some light transformation to turn this string coming from the PLC into a Boolean, et cetera. So I've done that mapping. And then when I do a test read, tags are gone, poof, like magic, right? It's this nice, I don't care the make, model, where the packing machine is, I have this nice model data. So what can I do with that? Well, the first thing I can do is I could push that to, let's go. I don't know why all these flows are on. I'm going to turn a few of these off. All right. So the first thing I could do is I could send that to what I'm calling my local broker, right? So I have another set of flows in HighByte. And what I'm going to do is just set up a flow that grabs that packing machine we just find, and it's going to publish it out over MQTT. So I'm going to turn that on. I'm using the local HighByte broker here, but you could use any broker. And I'm going to launch our UNS client to go look at that data. In here is the nice model data we created. So this is being published into MQTT. I could just as easily go into that flow, and instead of publishing to MQTT, I could decide I'm going to send direct to Snowflake, right? So let's say I don't at the moment want to adopt MQTT technology and all the stuff behind it. I just want to send model data strictly to Snowflake. So assume I'm not going to remove this, assume it's not here, but I'm going to take the same model data and send it out. to Snowflake, and then we'll go look at what that looks like. So I'm going to open up a new tab. I'm going to select the same database, and I'm going to say select everything from Packers. And we didn't look at that output, but I'm simply sending that data to a Packers table in Snowflake. And you can see now we have this nice, nice model data. And the beauty of this too is, I'm not going to totally show this, but let's turn this off and jump back to flows. And what I'm going to do is, instead of just one packing machine, I actually had 3, if you remember, in the OPC server. So I'm going to use a feature in HighByte called templating to quickly enable those. I'm not going to go through how I configured that completely, but you can see I'm just ranging a value and I'm dynamically feeding that in. So when I read this, I get all 3 packing machines. Again, I can turn that on and publish that to MQTT. I can also, same thing, I'm just going to drag the Snowflake output onto here. So now the only difference is if I go into UNS, now I have 3 instead of 1, right? And if I go to my table and I started filtering this, you can see Packer 1, 2, and 3 come online. So I can quickly kind of enable that. Now, what's the difference between this and this? Answer is a whole lot of work, right? Like suddenly I have these nice clean tables. I'm using data ops to control that data model and the data flow. I can decide, right, to send direct to Snowflake. The other thing I can do in this demo real quick is, let's say that I don't want to connect. I don't want to send direct to Snowflake. I actually want to publish to my local broker, and I want to take it from there and publish that to Snowflake because I'm using data ops and that's just my strategy. I want a different data flow. So what I can do as well is I can go back to my 2 Snowflake flows. And what I have is an MQTT to Snowflake. And what this is doing is I'm connected to that local broker listening on the Packers topic. So I'm grabbing all of these as they come in. I do the test read and you'll see just the latest one. This is caching the latest message. And if I come back here, this is event driven. So every message that comes in here, I'm going to queue that and send it out to Snowflake on that same thing. So I have the other flow disabled, but if I turn this one on, it's the same data model. It's just, instead of going direct to Snowflake, it's going MQTT to Snowflake. I've just kind of changed the data routing and it lands in the same place. So I have that flexibility with a data ops solution to decide, do I want to go through MQTT to Snowflake? Do I want to go direct to Snowflake? I probably want a buffer stage in here so that I'm optimizing my payloads too. And you can do that with data ops. So quick highlight of that example, the difference between raw data and model data, big difference. What's the value of data ops? It's the control over exactly how that data flow works and the modeling of the data.
Aron, that's so cool.
Yeah, I think it's cool. Yeah.
Good job to you and the entire R&D team. That's pretty impressive. What I'm going to do is jump into the next question, and this is going to be a quick one, Jeff. I'm going to send it your way because I think Aron has maybe another demo for us around this. And of course, we're going to cover the topic of Sparkplug here. Great question from Amy. Any lessons learned on how to best handle Sparkplug B messages from PLCs to optimize usefulness of Snowflake Cloud applications? Jeff, I'm going to give you 2 minutes, and then I love to see another demo from Aron. Excellent.
So at a high level, Sparkplug is really just another protocol to move data. It's predominantly oriented around the telemetry world, right? Has origins again in the energy industry. It's kind of a device to SCADA or a gateway to SCADA type protocol. But ultimately, data after it's brought into Intelligence Hub, data is data. We focus on data to the needs of consumers, right? And so a lot of times when people need to consume data, they're actually consuming from multiple places. All of that data gets normalized, so it doesn't really matter as much. But what I really wanted to kind of focus on, because I think this is an excellent question, it's not so, and I want to answer a little bit different and go beyond just thinking about Sparkplug, but think about is what is good, useful data for Snowflake? So I have a simple example here where let's suppose we had a use case, maybe we're having some sort of product cleanliness or some sort of defect issue, right? And we have maybe we have a filtration process, maybe we're measuring some pressure or something like that. And maybe also some instrumentation that measures maybe the amount of particle debris or something like to gauge our cleanliness essentially. But when you start working with industrial data, right, it's coming off of some sort of obscure field bus or wherever it came from, right? It's very, very raw. And a lot of times, even when people, after they expose it as, MQTT or OPC-UA or any of the kind of more modern protocols, a lot of times they're very lazy, right? Even the device manufacturers are lazy. They'll literally rip off their old field bus interface and they'll slap on their new IoT protocol, and they're still sending the same data. The problem is that data is still very cryptic to use. And a lot of times when people take this data and they turn it into they expose it, they're still using these cryptic identifiers. So we don't know what F8:10 means, and even then or whatever, like maybe if you're a domain expert, you're familiar with the process, maybe you could say maybe that's like debris value or something like that, but again, it's a very foreign way to look at data. The problem is that if we just took this data and put a timestamp on it and threw it into Snowflake, it'd be very hard for a domain expert to do something useful with it. It'd be very difficult for them to understand that where is this data coming from? What operator is running this? What material am I running? When was this asset last worked on, and so forth. So what Intelligence Hub can do is it can take those raw values and essentially enrich them. It could add context about asset hierarchy type information to basically allow us to distinguish how this instrumentation is different from other instrumentation. It could bring in manufacturing MES type data, right? It could tell us what are we actually producing? What is the material that we're working on? Which customer is this for? Which employee is working on this? And by enriching that information, ultimately we can land that data into Snowflake. And a data scientist or a domain expert within Snowflake can easily construct relationships because they're working with an enriched payload. They can join all their different enterprise data sets and build nice analytical dimensional models for their use cases. And that accelerates their involvement. If these payloads weren't enriched, it would require a lot of domain expertise to understand that cryptic value at 1 o'clock is related to a MES record that was captured at 8 o'clock. That requires a lot of tribal knowledge to be able to do that. So by enriching those payloads, essentially, that allows you to accelerate your use and the value that you get out of Snowflake.
Perfect. Thank you, Jeff. Aron, can we take a look at this inside of the Intelligence Hub?
Yeah. Can you see my screen? Or do I have to reshare?
You'll have to reshare.
Oh, man. It says resume screen.
I like that HighByte is easier to use than our
This is
Webcast
operator
platform.
error. I'm not going to blame Big Marker on this one. Yeah. All right. Can you see it now?
Yeah, it looks good.
Okay, perfect. So this use case is I've already modeled the data in another source system. I'm going to use Ignition. This could be Asset Framework and Pi. It could be another system, right? And I want to leverage that and get that into Sparkplug. And I want to leverage those model definitions. And I do not want to redefine those in HighByte because that just seems like a waste of time if they're already there. So what I have for this demo is I have Ignition up. In Ignition, this is kind of a mess, but I've got two UDTs. So I've got a boiler one that's pretty simple. And then my motor one is grown over time. It's a bit of a mess, but it'll work for the purposes of this demo. So these are my modeled things, UDTs and Ignition. In my address space, I've set up Ignition to publish Sparkplug to my local broker under the Portland topic. So I have boilers, and that's the one instance of a boiler one, and then I have these two motors. This is a fairly fictitious example, but just kind of go with me. So what you need to do is you need to go into HighByte and tap into that Sparkplug input. So I have I'm using the HighByte broker again. You could use any broker, but I'm using HighByte 1885. And I've created a Sparkplug input, and this Sparkplug input is listening to the entire Sparkplug namespace, right? So in this use case, I want to do very low touch. I just want to try to move the data from Ignition, the model data, into Sparkplug, into Snowflake. So many technologies to keep track of. Okay, so what I'll do is a test read, right? And when I do a test read, what you're going to see, that actually doesn't look, it looks like my motor data is not publishing, which is interesting. We'll try to, I'll restart but you can see this is part of the Ignition address space. So the boilers part did come through for whatever reason. Oh, I thought I did that. There you go. We hit it anyway. All right, so restart the demo. There we go. All right, let's try it again. Resave the connection. So we're going to try to get it to rebirth all the data. Expand. There we go. So that's the motor information, and then the boiler, I think, is slightly delayed. Yeah. Okay. So this is the full namespace. So my Ignition trial reset, we got through it. And there's the data. So I want to take this and get it up into Snowflake. So what I'm going to do is go create a data flow. I'm going to go to the Snowflake group, and this is Sparkplug to Snowflake. Again, very low touch. So what I'm doing is grabbing that entire input we just looked at, and I'm going to send that out. In this case, I need to do some massaging of the data. So every event that comes in through Sparkplug, I'm going to send it through this flow to this pipeline. What I'm going to do is turn this on. We'll go take a peek at what this pipeline is doing. So this is the pipeline feature in HighByte. One of the really cool things we added in this release is replay. So I use this all the time when I was kind of developing this demo. But if you go in and you turn on tracking, what you can do is per event that comes into the system now, you have a queue of 100 events, and you can actually track what happened as they went through this pipeline. So you get timing to see how long each stage took, and you can actually drill in here and look at the activity. You can see this is the JSON payload. This is the Sparkplug data that came in. In this case, I have a light transform here that's ripping through that whole payload, and I can share this if anybody's interested. And it's looking for modeled things. So it's looking for anything that has a UDT definition in the payload. It's creating a unique message out of that. And then it's sending that to a buffer to be more efficient and sending it to Snowflake. So it's queuing up like 10 motor updates, 10 boiler updates, and then it's flushing that to Snowflake. And then Snowflake, in this case, I've got a model that's the table name's dynamic. So it's called model. I probably should have called it Sparkplug B, but model underscore. This buffer key is the actual UDT name, and you'd see that if you looked at the transform. So what this means is I can now go, now that this is running and there's no errors, right? I can go up into here and say, let's use this one, select all from model motor. Motor was the name of the thing, the UDT in ignition, right? And we'll hit query. And I already got a bunch of data in there. It's taking a minute, but you can see here's the definition, just like we were looking before. But this model definition is coming from ignition. I've done nothing to modify it, and I have the path information, and I can enrich this with other information like edge node, etc. But this is just flowing. So with this flow set up, I could dynamically go into ignition and start changing things, adding UDTs, adding instances, and those would end up as unique tables in Snowflake with the data in there. And I think the beauty of this approach is you can create the pipeline that's the very hands-off approach that pushes everything. Or what I started to do over here, I won't show it in this demo, you could start to modify this to say, I only want parts of the namespace, or only want certain modeled things to go up into Snowflake. And you start have finite control over what's created in Snowflake, when it's created, the shape of that thing, et cetera. So it kind of gives you the hands-off approach and then the ability to fine-tune that as you progress.
Love it. Thank you, Aron. And you know, I feel like at this point you've really answered this question, but just to put a bow on it, and I'll kick it right back to you, Aron. This is a question we got from Aristoteles in the registration form. Does the Sparkplug metric payload align with the schema in Snowflake, or is more flexibility and governance desired to shape and contextualize the payload? Quick answer to that one, Aron.
I think to start, you can use the Sparkplug template stuff. I think over time, you're going to want more governance and flexibility in managing the payload. I don't think you want a funnel of your Sparkplug namespace all the way up into Snowflake and no control over that. But as a starting point, all the information is there to go create tables through the schema. Just make sure if you're using ignition in the exporter, you turn on UDT definition so it doesn't flatten tags. You can look through the documentation, but you want to make sure you're publishing that model data because you don't have to as part of Sparkplug.
Great. Okay, I'm going to move on to the next question. And actually, I'm going to combine this one with the next one because I think they're sort of related to each other. This first one is around historical data that came to us from Eric and how time series historical data, its relationship to the UNS, and also the relationship between UNS and data ops, which is, I think, kind of in some ways the answer to that question. So, Aron, I think you even have maybe a demo queued up showing Pi data movement into Snowflake. Do you want to answer these two questions while you do the demo?
Yeah, let's just jump straight in. So can you see my screen
again?
Make sure I'm...
Yeah.
All right, so...
You got it now.
And there's one more demo after this. So I'm going to go pretty quick through this. We could spend an hour talking about Pi data into Snowflake and how that all works. I think the important piece is you do not want to run this through an MQTT broker, right? It's very different than real-time data, exception-based through MQTT. This is large amounts of data, infrequently sometimes transmitted, and it makes sense to have data ops manage that data flow outside of real-time data access through MQTT. So To set up this demo, I think that the key points of this is with our Pi connector, and I've got a Pi instance here with AF set up to simulate this fertilizer line, right? So I have some Pi data points I'm simulating. This is kind of my structure. It's a line with a few pieces of equipment on it. The important part is Pi has metadata. So all of that information in that tree, you could consider metadata, you know, the assets, et cetera, the models. It has historical data. That's the data that's been stored, you know, from time X to time Y. And it also has new data. So data changes, change data, late data. So those are the three types of data that come from Pi. The important part is in HighByte, you can access all three. So here I have an asset metadata input that's set up to read that line. So if you look at this, this is all the metadata you need that's coming out of that tree, right? So it's the name of the elements, it's all of their attributes, if they're linked to Pi points and what points they're linked to. So that's all the information you need around the metadata coming out of Pi. The other two inputs, I have one on point history, and I won't jump into this too much, but this is a condition that just goes through that metadata and answers the question of like what points are actually referenced in here. It pulls those points out, and then you can turn that into a raw query to say, give me the history for those points. So it's more dynamic. And here I'm just going back 10 minutes. You would probably set this up and go from time X to time Y in history in 1 day chunks, for example, and process this input. And the last one is the data changes. So this actually is using referencing the same points. And when you do a test input here, what this is showing, this is the new data coming into Pi, or data that's changed, or data that's been deleted. Add means it's new data coming in. So we have access to the 3 data sources coming from Pi. The next piece is you just need to flow those into Snowflake. Similar to the Sparkplug approach, there's the easy way, right? There's kind of like the big funnel it all, do some processing in Snowflake, and then you can become more prescriptive. I'm going to show you kind of the simple way, and then I'll just describe the more prescriptive. So here's an example of we're taking that metadata for the whole line, and we're just publishing that to an AF raw table. And I'm not going to turn that on at the moment. This is the AF metadata. You'd probably do this once a day, right? Because the stuff isn't changing AF raw that often. But you can see with our Snowflake streaming output, basically the way that works is it's a JSON payload. The first attribute in that payload becomes a column name, and anything that's more complex than that has hierarchy, Snowflake can handle JSON. So we just embed it as JSON. So this in here is exactly this structure, right, with all the metadata in the row. So over in here in attributes is like this thing's called the pressure, and it's linked to this Pi point. It's all the metadata you need. So that's how to land the metadata in there. And then those other flows are just set up to land the history data. So this flow goes and grabs the history data, lands it in a points raw table. If we were to look at that real quick, it's just a flat table that's very long that has the point name, the point ID, the value, and timestamps. This is kind of OPC-like data, right? But the reason we can do this is because we have the metadata from AF. So this isn't useless. There's no extra work here. Like we have all the information we need to make use of this, so we can just land it in a long table, and that's more efficient in Snowflake. And then the last piece there is just a very similar flow where I'm taking the point changes and I'm actually putting it in the same table because it has the same data shape. If you're dealing with change data, late arriving data, you might want to land that in a separate table and handle merges in Snowflake. But the idea now is that all the data you need is there. You can then go run stored procedures on the AF data to break that out. So in Snowflake, you can write queries like, give me the pressure on line 1 crushing machine from time X to time Y, and that can come out of Snowflake. So this is kind of the easy way, the simple way to get started. We're working with Snowflake on like a more advanced data model where some of that modeling and transformation actually happens in HighByte, right? So that we can deliver the data in more precise tables in Snowflake, so that if the data is coming from Prophecy Historian, OSI Soft, PhD, Honeywell Historian, it doesn't matter. By the time you get to Snowflake, you can write the same queries. Or a Pi instance that doesn't have AF, we can kind of augment that. So I'll stop there. That could be its own session, but important part, don't send it through MQTT. You want to do it direct. Yeah.
Perfect. Okay, so let's talk about the other direction. What about getting data from Snowflake back down into the factory? Does that pass through the UNS as well? Aron, this will be the last question for you, and then I'll give you a break and head back to Jeff.
There we go. All right, this is it. This is the coolest part of the demo. So let's. I'm glad we got it in and got time. So this whole time I've been publishing data, and you see the Sparkplug stuff coming in from Ignition. So just ignore that.
You're going to want to share your screen again. I keep messing with you, Aron. Technology's
not working for me. All right, there we go.
There you go.
Is it okay? So this is the MQTT broker, the namespace I'm pushing the UNS into. And so what I want to do here is I want to augment it with MES information and ERP information. So if I go into my 2MQTT, I've got this flow that's just pushing the model data, the packing machines, right? That's solely coming from here. What's interesting in that data is we have the order number that packing machine's working on. So that's coming from the PLC. So we're going to use that as the index. And I've got this separate flow that's taking those same packing machines and it's pumping it to a pipeline that's going to do this kind of augmentation. And I'm just going to turn that on. And then we can jump to pipeline. And we'll turn on, tracking's already on. So what we can see here, if we go in here, what this pipeline is doing is per packing machine comes in, the first thing it's doing is say, hey, did the order change? Right now I have the order changing every 10 seconds. If it didn't change, I have nothing to do. Just skip it. So this stuff's grayed out. It's not being run. If you go through here, every once in a while, there's one that has a longer timestamp. It took longer to process. That's because the order did change. So when the order does change, what this is doing is it's doing two things. It's going out and reading the local MES with the order number, and it's adding the order information to the UNS. And then it's going to go out and read ERP information, in this case from Snowflake, right? And it's going to augment that into the UNS or into the broker as well, into the namespace. So if you look at how I'm doing that real quick, so it comes in this step. Let me exit replay so we can go see it. So here we're just using a feature in HighByte where it's a little condensed here, but I went and set up a separate SQL connection to grab the order information. We're passing in the order info, which is coming from the data that's from the PLC to do the lookup. And then when we send it back out over MQTT, we're just going packing machine, the packer name, and then, oh, I just messed that up. Reset. Drag and drop. There we go. So we're just adding it as an order at the end. Similar to the ERP stuff, what we're doing is we're going out to Snowflake. We've created a JDBC connection to Snowflake, which allows us to write SQL queries to pull data back in. And again, this is kind of condensed, but we're doing the same thing. We're passing the order information in. And if I actually jump out real quick to show you that, because it's an interesting query. Snowflake JDBC. So here's the query. And it's a complex query, right? So I'm using SQL. I'm saying, I'm looking across two tables. So get me the customer name and the product name from orders table. I'm going to look up by ID, and then I want to cross and join the customer and product tables and pull those information. So the use case here is like, hey, I've got an operator at the end of the packing machine. I actually want to show them what customer's order they're working on, assuming I can do that. And it's not like privacy thing. They can see like what customer they're actually producing the product for as like a motivation. And then up in Snowflake, I set up the tables. I set up an orders table and all that, but we won't dunk into that. So I just turned that on, and what that means is now I've got augmented into my real-time data that's coming from the machine. I've got an orders table that's pulling from the local SQL MES, the MES system, which is the local SQL server. It's got some weird spacing, but ignore that. That's just my test data. And then customer. Right. And in here, all the customers are Walker, UNS, single source of truth. It's just a call out to Walker. I mean, he's kind of the reason we're in this UNS mess anyway, but it's all good stuff. He's done a great job kind of championing this concept. So tip of the hat to him. And it's the same across all. But this is just an example of, maybe Snowflake has an integration with the ERP, and it's easier for the local system to reach up into that and pull the data back down. Right.
Aron, so powerful. And you even worked in a little Easter egg. So props to you on that. That was pretty funny. That's awesome. I'm going to launch a poll as I set up the next question. So the question is, if you are somewhere in your UNS journey, what applications are you using to consume data from the UNS? You can answer that as it becomes available, and I'm going to go ahead and load the next question. We just have a few more left. That concluded the demos, but just a few more questions to go that I think are good, and I want to make sure we get to them. And Jeff, I'm going to kick this back to you. You only have a couple minutes for these questions, so sorry to cut you short, but the first one is, what are some of the advantages and disadvantages of using a UNS architecture with a SCADA system? Can you talk about that, please?
Absolutely. So it really, long story short, it depends on how you define SCADA. SCADA in the past 10 years has become it's changed a bit. SCADA in the old days, as the name implies, it was literally supervisory control and data acquisition. So it was almost like a process control node. It was part of the plant. It was part of an area, or may have been sitting on a line, right? And so in some architectures, SCADA is like a process control node. It's just part of the plant. It's an excellent source of data. All the process control nodes feed up to it, and it's a great place to be able to pull data in. But additionally, SCADAs are mostly focused on telemetry data. Sometimes they do have connectors to databases and things like that, but they're not really designed. They're not really qualified as middleware. If you asked an IT person to say, "Hey, would you like to use the SCADA to run our service bus for all of our ERPs?" They would probably cry. So as a result, you generally need kind of more rich data engineering capabilities to be able to interoperate with things like ERP nodes, MES systems, quality management systems, EAM systems, even files, right? So that's one where I'd kind of consider like traditional SCADA type architectures. But one of the things that we started to see is that a lot of times people don't necessarily need SCADA as a process node. And sometimes they're just sort of using it almost as an IIoT type platform. They're using it for dashboarding. They're using it for visualization. So instead of SCADA being kind of a net producer in the architecture, it ends up being a net consumer in the architecture. It's an excellent place for people to be able to get visualizations, get notifications where things are happening. It's more of a passive node in the architecture rather than something that's kind of doing command and control or supervisory relationship with automation. And lastly, sometimes some customers don't have SCADA at all. They don't see the value of it. Their automation landscape looks kind of completely different. And we see sometimes more sophisticated scenarios where they say, a SCADA of just visualizing name value pairs isn't enough. We might actually need HighByte to compose a series of models and feed them into a digital twin, and then maybe we'll visualize off of our digital twin. Some of our customers even go to that extent. So it can vary very widely.
Jeff, I have a follow-on question for that. So what's the tipping point, like, for when a customer needs HighByte Intelligence Hub? Is it the architectural complexity? Is it, they're looking at more than one site? Is it the size of the site? Like, what can you say? Is there a complexity or size factor that comes into the realization of, oh, I need HighByte layered on top of a SCADA solution?
Excellent question again. Yeah, I would say, we have some of the, largest well-known companies in the world, like, in pulp and paper, luxury consumer goods, bearings, and so forth, right? And then also we have some very innovative, like small startups, one site on there. At the end of the day, all of them had something in common where they at least started with one site and they had an interoperability problem. I think it's useful to kind of dive into this rather than saying, hey, you must have X amount of nodes or X amount of sites, or you must be moving a certain amount of data. I think it's useful to kind of put it around on what kind of problems that you're looking to solve.
Perfect. Okay. So, I have one last. Oh, sorry. Am I cutting you off?
Yeah, sorry. Yeah. Sorry.
No. It's all good. Okay.
Yeah. So the first thing is I would just say, do you have more than one application? Because, if you've modeled all your data inside of one application, and you decide to add another, maybe you might be able to depend on that application to pull data out of it. But what happens when you have 5 more? Is that even a stable approach? So there's a lot of benefits to modeling independent of the application and to be able to reuse the engineering. I've seen scenarios before where you've built something in an application and you find that actually I don't like that application for that job, and it turns out all that engineering work is now stuck in there and you can't reuse it. The other scenario is just like simply evolving requirements. A lot of times when people, they set up an integration platform, or they take an approach, they might think, hey, I'm consolidating my solutions, I'm getting rid of point-to-point connections. But in practice, a lot of times they're often just making point-to-point connections inside of one platform. And so the real telltale sign is, could you take that engineering work and now move it to a different site or move it to a different use case, and would it work? And a lot of times that doesn't work, and it turns out to be actually quite fragile. So I'd say, do you have evolving requirements? Do things change in your environment? The other thing I would say is, do you have variability across lines, sites, and so forth? How do you keep data consistency, and how do you do that at scale? That's another factor that our customers, regardless of size, regardless of architecture, encounter. And lastly, I would say, and this is probably the most important one, is really, do you want to involve a team? Typically with OT-centric tools or things that are focused on manufacturing, it generally attracts a certain persona or almost a clique within the enterprise that only manage those solutions. I think for things to really scale up to be effective, you need to involve the application owners, the data scientists, basically the consumers of data. You need to involve the OT domain experts that understand those sort of source systems. But you also need architects to be able to instill best practices and accelerate those deployments and think about them sort of thoughtfully. And likewise, you can't leave IT out of the loop, because IT would otherwise just simply say, I don't like what you're doing, it's not compliant, no. It's much more effective to share a no-code, low-code interface with everyone where they can see what's going on. If you think about it, mechanical engineers use PLM systems to update their drawings. Software engineers use GitHub to keep their drawings. You essentially need a platform to lifecycle your integrations. And so that's essentially what Intelligence Hub provides.
Man, Jeff, that was a smart answer, and I'm really glad I didn't cut you off from giving that. That was really succinct. I think that's like a hard question often to answer, and you just did that beautifully. So thank you. Aron, one last question, and this is it, and we're gonna wrap up with this. So looking ahead to the future, the question is, where is the UNS going next? What's the future of UNS? And give us the goods.
The big question. Yeah, so we're starting to work on the new major version of the product 4.0. What I'll say is we're very focused on, we're very strong in like the data, moving data between systems. We're going to see a lot of enhancements around metadata. So I would say that's like the concept of a namespace builder. The idea that you can kind of build a UNS in HighByte, right? Kind of your the metadata and access to the data in HighByte, and also introduce like a query language that allows you to build that and then pull either the whole thing out or parts of it. So if you want to take your namespace and you want to project that into MQTT for real-time data access, that should be really easy, right? If you want to ask questions of that namespace and say, get me all the boilers that have a temperature reading over 90 degrees and publish that over MQTT, or send that to Snowflake, or so this idea of like build it once, make it dynamically queryable, and be able to move that between systems. I think that in our mind is the future of UNS, and that's kind of where we're headed. And happy to share more of that as we progress, because we're kind of deep in the code now.
It's awesome. I'll share this with everyone just to kind of close. So we ran a few polls throughout the webcast, and this last one on your UNS journey. Overwhelmingly, you're exploring right now. So I hope that this webcast was helpful as you do research and try to understand more how a UNS might work for your company. And if you have any questions, of course, you know how to reach us. And just to put a bow on the housekeeping, we will send out a recording within the next 24 hours. But if you want access to any of the slides, incredible reference architectures that Jeff put together, please just let us know and we'll get them to you. And with that, I just want to say thank you to John and Brad for doing an expert job answering the Q&A chat throughout this presentation. And thank you so much to Jeff and Aron, who put so much work and thought into these webcasts for all of us. So thank you, everyone, and thank you all for coming.
Yeah, thank you.